Welcome back, deep divers. Today we're going to get into something super cool, emotion regulation. Seriously, have you ever wondered what's actually going on in our brains when we try to keep our cool
It's like a constant battle between logic and...
feelings?
Yeah, exactly.
And that's what we're diving into today.
We've got this research paper.
It's dense, it's packed with brain scans, all that fun stuff.
Oh yeah, they went deep on this one.
And our mission is to figure out, okay, is emotion regulation its own thing in the brain?
Like, does it have its own zip code up there?
Right. Or is it just part of other brain functions, like fear or reward?
It's a big question, and it could change how we think about mental health.
Huge. So if it turns out that emotion regulation is its own separate brain function,
That would be huge, because right now we kind of lump it in with...
everything else.
Yeah, like it's just a symptom of anxiety or depression.
But what if it's not? What if it's the root of the problem?
Okay, so before we get too far ahead of ourselves,
Yeah, let's back up a sec.
what exactly is emotion regulation? Like in simple terms. All right, think of it this way. It's basically managing your emotions to match your goals.
Okay, I think I get that.
So like, say you're about to blow up at your boss,
Oh, I've been there.
but you manage to take a breath and hold back.
Because losing your job is not the goal.
Exactly. You're regulating your anger to achieve your goal of, keeping your job and maybe getting that promotion.
Right. Or you're terrified to give a presentation, but you somehow manage to channel that nervous energy into a killer performance.
You nailed it. That's emotion regulation in action.
Okay, so it's about more than just feeling happy or sad. It's about what we do with those feelings.
It's like emotions are the raw material, and emotion regulation is how we sculpt that material into something...
Usable.
Exactly. Into something that helps us thrive.
So how does all of this fit into the RDOC framework?
Right. It stands for Research Domain Criteria.
Okay, and what is that again?
Well, it's basically a new way of looking at mental health. Instead of just focusing on symptoms.
Instead of saying, oh, you have anxiety, they're trying to look deeper.
Exactly. They're looking at the underlying brain functions that might be going haywire.
So it's like a map of different mental processes.
Exactly. Like fear, reward, attention.
Right. All those things our brains do.
And the big question here is, does emotion regulation fit neatly into one of those existing categories?
Or is it something totally unique?
Right. Like its own separate domain.
And to figure that out, these researchers analyzed a ton of brain scans. They were comparing activity during emotion regulation tasks to what was happening in other RDOC domains.
Right. So they're looking for patterns.
Trying to see if there's something special about emotion regulation.
And what they found is emotion regulation does use some of the same brain areas as other domains. But the combination, the way those areas work together, is unique. You can use flour to make cookies and cake, right?
Sure.
But they're not the same thing.
Totally. The ingredients are similar, but the end result is...
completely different.
So what are the special ingredients in the emotion regulation recipe? Which brain areas are we talking about here?
Okay, so two key players are the inferior frontal gyrus and the medial frontal gyrus. So the inferior frontal gyrus, that's like our impulse control center.
Oh, I need more of that.
You too?
Like when you almost say something you'll regret.
And you stop yourself just in time.
That little voice that's like, don't do it.
That's your inferior frontal gyrus saving the day.
I love that little guy. What about the medial frontal gyrus?
Okay, so that one's all about planning and flexibility.
Like thinking ahead and adapting to the situation.
You got it. It helps us come up with a game plan for dealing with our emotions.
So, if the inferior frontal gyrus is the brakes.
The medial frontal gyrus is the GPS,
Okay, that's a great analogy.
navigating the emotional terrain.
I like it.
So it's not just about suppressing our feelings.
It's about being smart about how we handle them. So emotion regulation is kind of a sophisticated operation going on up there.
It really is.
Yeah.
And it's not just happening in healthy brains either. The researchers also looked at brain activity in people with various mental disorders.
Like depression, anxiety, things like that.
Exactly. To see if there were any consistent patterns.
Okay, let's dive into that. What did they find?
Well, here's where things get even more interesting. They found that even though there were some differences in brain activity between disorders,
Okay, so different disorders, different brain patterns makes sense.
but there was one striking consistency, no matter what the diagnosis. People were consistently activating the dorsomedial prefrontal cortex when trying to regulate their emotions.
Wait, back up. The what now?
The dorsomedial prefrontal cortex.
And what does that do?
Think of it like your inner therapist. It's the part of your brain that helps you make sense of your own thoughts and feelings.
Like self-awareness.
Exactly. Introspection. understanding your own mental states.
So no matter what the specific disorder is, difficulties with emotion regulation
And specifically, activity in this part of the brain.
could be a common thread.
That's what the research suggests. It's a pretty big deal because
It could change how we think about mental health altogether. Instead of just focusing on the symptoms of a specific disorder,
we can start to target those core emotion regulation skills.
which might be the root of the problem in many cases.
Exactly. And that's where things get really exciting because if we can understand how emotion regulation works in the brain
We can develop better ways to help people who are struggling.
and maybe even prevent these problems from developing in the first place.
This is blowing my mind. We're talking about potentially rewiring the way we think about mental health.
It's a paradigm shift.
I love it. But how did they actually measure how distinct emotion regulation is? It's not like they can just look at a brain scan and say, yep, that's definitely emotion regulation happening over there.
You're right. They needed a more precise way to compare these different processes.
So what did they use?
Enter the Dice coefficient.
The what?
The Dice coefficient.
Okay, you're going to have to explain that one.
So basically, it's a statistical tool that measures the overlap between two things.
Give me a visual.
All right, picture two Venn diagrams.
Okay, got it.
One represents brain activity during emotion regulation, and the other represents activity during another mental process, like fear processing.
Right.
The Dice coefficient tells you how much those two circles overlap.
So like a high score means they're very similar,
Exactly.
and a low score means they're more distinct.
You getting it?
So what did the Dice coefficient reveal about emotion regulation?
Drum roll, please.
Hit me with it.
Emotion regulation had a low Dice score with all the other RDOC domains.
Wait, low overlap, does that mean?
It means emotion regulation really does seem to be its own distinct thing.
Whoa, like its own separate category.
It has a unique neural fingerprint, suggesting it's not just a subcomponent of other brain functions. While emotion regulation is its own thing,
It's clearly intertwined with other mental processes.
it's all connected.
So which domains showed the most overlap? Where do those interactions really stand out?
The strongest connections were with cognitive and social processes.
Which makes sense, right? Thinking and interacting with others often triggers strong emotions.
All the time.
And we need to regulate those feelings to navigate those situations effectively,
It's like our brains are constantly juggling these different demands.
trying to keep everything in balance.
And emotion regulation is the key to making it all work.
Hey, I'm starting to see how this all fits together, but I'm curious, if there's overlap with every domain,
Right.
how can we still say that emotion regulation is distinct?
Good question. So to really pinpoint those differences, they compared brain activity during emotion regulation to activity during tasks involving valence. Like the goodness or badness of an emotion.
Oh, okay. So like happy versus sad, excited versus fearful.
Exactly.
Yeah.
And what they found is that while emotion regulation obviously deals with our feelings,
Right.
it's not just about whether those feelings are pleasant or unpleasant.
Interesting.
There were distinct activation patterns in specific brain regions during emotion regulation compared to simply processing the valence of an emotion.
Like those key areas we talked about earlier, the inferior frontal gyrus and medial frontal gyrus.
Exactly. Those areas were much more active during emotion regulation.
So it's not just about feeling good or bad, it's about engaging those control and planning mechanisms.
To manage our emotional responses in a more sophisticated way.
It's like emotion regulation is the conductor of an orchestra.
Ooh, I like that.
It's not creating the music itself, but it's shaping how those individual instruments
Our emotions.
play together to create a harmonious whole. So what about comparisons with other RDOC domains? Did they find similar distinctions when looking at things like arousal or regulatory systems?
Absolutely. For instance, when comparing emotion regulation to arousal.
Which is like our level of alertness or excitement, right?
Exactly. They found distinct activity in areas like the middle frontal gyrus and middle temporal gyrus.
Okay, remind me what those areas do again.
All right, so the middle frontal gyrus plays a role in decision-making and working memory, and the middle temporal gyrus is involved in processing language and social cues.
Right, which are both important for understanding and navigating emotional situations.
So even though our basic bodily responses like heart rate and alertness, that arousal factor, are definitely part of the picture.
It's like emotion regulation is the CEO of our emotional world.
I love that.
Making decisions, delegating tasks, ensuring everything runs smoothly.
And this CEO has a lot of different departments to manage.
Right, we're talking about a complex interplay between multiple brain systems.
Exactly. And the researchers actually did a deep dive into those different departments.
This is where things get really granular, huh?
They compared emotion regulation to various subdomains within the larger RDOC categories.
Okay, let's talk about some of those subdomain comparisons. What were some of the highlights?
One that really stood out was the comparison between emotion regulation and cognitive control.
Okay, cognitive control. Remind me what that is again.
It's essentially our ability to focus, make decisions, and resist impulses, our executive functions in action.
Our mental willpower.
Exactly. And the researchers found that both emotion regulation and cognitive control rely heavily on the inferior frontal gyrus.
That impulse control center we keep coming back to.
It's a busy little region.
So emotion regulation is like a specialized form of cognitive control, specifically focused on managing our feelings.
That's a good way to think about it. But they also found differences between the two.
Highlighting the unique aspects of emotion regulation.
Exactly. For example, there were distinct activation patterns in the superior temporal gyrus, which is involved in language processing.
Language.
Interesting. And the middle temporal gyrus, which is linked to memory and understanding meaning.
So maybe emotion regulation is drawing on our memories and past experiences to help us manage our feelings in the present moment.
That's a very insightful observation.
Yeah.
It suggests that emotion regulation isn't just about reacting in the moment
It's about using our past to inform our present.
and to shape our future.
Mind-blowing. What other interesting comparisons came out of those subdomain analyses?
Another one that stood out was the comparison between emotion regulation and declarative memory,
Declarative memory.
our memory for facts and events.
Oh, right, like
Yeah.
knowing the capital of France or remembering what you had for breakfast.
Exactly. And they found distinct activity in the medial frontal gyrus during emotion regulation compared to declarative memory tasks.
That planning and adapting area.
Right, so maybe emotion regulation is using that part of the brain to anticipate how we might feel in certain situations and plan accordingly.
Like, if I know I get anxious in social situations, I can use my medial frontal gyrus to come up with a plan for managing that anxiety before I even walk into the party.
That's a great example. It highlights the proactive nature of emotion regulation,
It's not just about reacting, it's about planning ahead.
being strategic with our emotions.
Okay, this is all incredibly fascinating, but I have to admit, my brain is starting to feel a bit overloaded with all these different regions.
I hear you. It's a lot to take in.
Can we maybe pause for a moment and do a quick recap of the key areas and their roles in emotion regulation?
Absolutely. So the stars of the show are the inferior frontal gyrus.
Our impulse control center.
Right. Then we have the medial frontal gyrus.
Planning and adapting.
And finally, the dorsomedial prefrontal cortex.
Our inner therapist.
Exactly. Those are the key players in the emotion regulation game.
Okay, that's super helpful. Now, you also mentioned the researchers did some fascinating comparisons between emotion regulation and language.
Right. It might seem a bit counterintuitive at first.
Because what does language have to do with managing our emotions?
Well, more than you might think. Language plays a crucial role in how we process and regulate emotions.
Really? How so?
Think about how we use words to label our feelings, express them to others,
Right.
and even change our perspective on them.
So like instead of saying, I'm totally freaking out, you might say, I'm feeling a bit stressed, but I'm going to take some deep breaths and figure this out.
Exactly. That kind of verbal reframing can actually help us manage our emotions more effectively.
It's like we're using language to coach ourselves.
Soothe ourselves, to reframe the situation.
Wow, I never thought about it that way. So what did the brain scans reveal about this link between language and emotion regulation?
They found distinct activation in the inferior frontal gyrus and superior frontal gyrus during emotion regulation compared to language tasks.
And those areas are involved in?
So the inferior frontal gyrus, as we've already discussed, is our trusty impulse control center.
Right, our mental breaks.
And the superior frontal gyrus is involved in higher level cognitive functions like planning, decision-making, and working memory.
Okay, so it seems like emotion regulation is drawing on these brain areas to help us use language in a way that supports our emotional well-being.
Exactly. It's all about using our words wisely.
Okay, we've covered a lot of ground here, but I want to make sure we circle back to the big question. Why does all of this matter? What are the implications of understanding emotion regulation as a distinct brain function, potentially even its own category within the RDOC framework?
This is where the rubber meets the road.
Right. This isn't just theoretical. It has real-world consequences.
Absolutely. This research has the potential to revolutionize how we diagnose and treat mental health conditions.
Okay, I'm listening. How so?
Well, instead of just treating the symptoms of a particular disorder,
Which is what we often do now.
right, we can start to target those core emotion regulation skills that seem to be disrupted across diagnoses.
So it's like treating the root of the problem rather than just pruning the branches.
Exactly. If we can identify the specific neural mechanisms that are malfunctioning,
We can develop more targeted and effective treatments.
that's the goal, to help people live happier, healthier lives.
I can see how that would be incredibly empowering for people struggling with mental health challenges.
Instead of feeling like they're at the mercy of their emotions
They can start to develop the skills to manage them more effectively.
and regain control of their lives.
This is starting to paint a very different picture of how we think about mental health. It's not just about what's going wrong in a specific area of the brain, but about how well we can manage our emotions across different challenges.
It's a more holistic approach.
And it gives me hope. But before we get too carried away, you mentioned that the researchers also did a separate analysis looking at emotion regulation across different psychiatric disorders.
Right. They wanted to see if those findings held up in real-world clinical populations.
Okay, let's dive into that. What did they find about emotion regulation in people with specific mental health diagnoses?
So they basically wanted to see, okay, if there was this consistent neural signature of emotion regulation in people with various mental health conditions.
So it's like looking for a common thread that runs through different types of mental illness?
Exactly. And guess what? That's exactly what they found.
Okay, drum roll, please. What was this common neural signature?
They found consistent activation in the dorsomedial prefrontal cortex.
The what now? Sorry, I'm still trying to keep all these brain regions straight.
The dorsomedial prefrontal cortex, think of it as our internal control panel for thoughts and feelings.
Our inner air traffic controller.
Yeah, something like that. It helps us understand and manage our own mental states. Like, are we stressed? Are we sad? Or are we about to lose it?
So it's like the part of our brain that helps us make sense of all the chaos. And they found this area was consistently activated in people with a bunch of different disorders.
Oh, yeah. A wide range: depression, anxiety, substance use disorders, even schizophrenia.
Whoa, that's a pretty diverse group.
It is. And it really points to the idea that emotion regulation difficulties might be a transdiagnostic factor, something that contributes to a lot of different mental health problems.
So instead of just saying, oh, you have anxiety or you have depression, we might need to start thinking about, okay, how are your emotion regulation skills?
Exactly. Because those skills might be the key to unlocking better treatments and better outcomes for people.
This is so cool. I'm starting to see how this research could really change things.
It has the potential to be a game changer.
But I'm curious about the details of this analysis. You mentioned they did it on different levels of specificity. Can you break that down for us?
Sure. So they started with a global analysis, basically pooling all the studies and contrast together, regardless of the specific disorder or type of emotion regulation task.
So it's like a big picture view to see if there are any overall patterns across the board.
Exactly. And they found that there were indeed significant differences in brain activity between patients with psychiatric disorders and healthy controls during emotion regulation tasks.
Okay, but I'm guessing they didn't just stop there. They dug deeper, right?
They did. They then looked at specific types of emotion regulation strategies, like reappraisal.
Reappraisal.
It's basically changing how we think about a situation to modify our emotional response.
No, like cognitive reframing.
Exactly. So like if you're feeling anxious about a presentation, you might reappraise the situation by reminding yourself that you've prepared well and you're capable of doing a good job.
It's like talking yourself off the ledge.
Exactly. And they found that, again, there were consistent differences in brain activity between patients and healthy controls during reappraisal tasks.
Particularly in that dorsomedial prefrontal cortex. So no matter how people were trying to regulate their emotions, that brain region seemed to be a key player in the differences between those with mental health challenges and those without.
That's a great summary. And they also did analyses focusing on specific groups of disorders, like mood disorders and anxiety disorders.
And I'm assuming they found that same differences in the dorsomedial prefrontal cortex.
Yep. Even when they narrowed their focus, the differences persisted.
Okay, so this really underscores the potential role of emotion regulation difficulties as a transdiagnostic factor.
It's a common thread that weaves through many different mental health conditions.
This is all starting to make a lot of sense. But I'm curious, did they find any brain areas where activity was decreased in patients compared to healthy controls during emotion regulation?
That's a great question. And the answer is yes. They did.
Okay, spill the tea. Which areas?
They observed decreased activation in the ventrolateral prefrontal cortex.
Another brain region. I'm going to need a cheat sheet for all these.
I know, right? The brain is a complex place.
So the ventrolateral prefrontal cortex, what does that one do?
It plays a crucial role in inhibiting unwanted thoughts and actions.
Our mental bouncer.
I like that analogy. It keeps those disruptive impulses in check.
So are you saying that people with mental disorders might be struggling to suppress those negative or intrusive thoughts that often accompany emotional distress?
That's a possible interpretation. It's like their mental bouncers taking a break.
And the disruptive thoughts are crashing the party.
Not good. But remember, we're talking about a complex interplay between different brain systems. It's not always a simple cause and effect relationship.
Right, it's more like a symphony of brain activity with all these different instruments playing their part.
A symphony that sometimes gets a little out of tune?
I like that. But this finding does point to the possibility that difficulties with inhibitory control might contribute to emotion regulation challenges in those with mental health conditions.
It's definitely something to consider.
Okay, this is all incredibly compelling, but I have to admit, with all these brain regions and functions, I'm starting to feel a bit lost in the woods.
I hear ya. It's a lot to take in.
Can we maybe take a step back and try to connect this back to everyday life?
Yeah, let's bring it down to earth.
What does all this brain science actually mean for someone who's struggling with emotion regulation in their day-to-day experiences?
It means there's hope. This research is showing us that emotion regulation isn't some fixed trait that you're stuck with.
It's not like you're born a good regulator or a bad regulator.
Exactly. It's a skill. And like any skill, it can be learned and strengthened.
So it's like learning to play an instrument or speak a new language. With practice and the right techniques, we can actually get better at managing our emotions.
That's the idea. And the more we understand about the specific brain circuits involved, the more we can tailor those techniques to individual needs.
So we're not just talking about generic advice like take a deep breath or count to 10. We're talking about potentially personalized approaches based on our unique brain wiring.
That's where the field is heading. It's incredibly exciting.
Imagine a future where we can pinpoint the exact brain regions that are causing problems and then develop treatments that target those areas directly.
It's like precision medicine for the mind.
I love it. But what might those interventions actually look like?
Well, there are already a number of promising approaches being explored. Neurofeedback, for example, allows people to see their brain activity in real time and learn to modify it through practice.
Wait, you can actually see your brain waves on a screen and then learn to control them.
It's pretty amazing, and it's showing some really promising results in helping people improve their emotion regulation skills.
Wow, that's incredible. What else?
There are also brain stimulation techniques like transcranial magnetic stimulation, or TMS, which can be used to modulate activity in specific brain regions.
So it's like giving your brain a little zap to get things back on track.
It's a bit more complicated than that, but that's the general idea.
This is all so fascinating, but I have to wonder, what about prevention? Can we teach these skills to kids before they even start having problems?
Now you're thinking big picture, and the answer is yes, absolutely.
Imagine if we could incorporate emotion regulation training into school curricula.
Teaching kids from a young age how to identify their feelings, understand their triggers, and develop healthy coping mechanisms.
It's like giving them emotional intelligence superpowers.
Yeah.
And not just for mental health, but for their relationships, their schoolwork, their whole lives.
Exactly. It would be a game changer.
But even beyond childhood, I think we can all benefit from learning more about emotion regulation.
It's never too late to learn new tricks.
It's a lifelong journey of self-discovery and skill building.
I couldn't agree more.
Okay, it feels like we've been given this incredible new roadmap to understanding our inner world and finding better ways to navigate life's challenges. But before we wrap up this deep dive, I'm curious about one more thing. We've talked a lot about these specific brain regions involved in emotion regulation.
Like all the key players.
But what about the connections between those regions?
The communication network.
Is there anything we know about how those pathways might be altered in people with mental disorders?
That's a brilliant question.
Yeah.
And it's an area where future research needs to focus. Because remember, the brain is not just a collection of isolated regions.
Right, it's all connected.
It's a vast network of interconnected pathways. Understanding how those connections might be disrupted in mental illness is crucial to developing truly effective treatments.
So it's like we've identified the key players in the emotion regulation game, but now we need to figure out how they're passing the ball back and forth.
Exactly. And those connections are what allow different brain regions to communicate and work together seamlessly. When those communication lines break down,
Things start to fall apart.
exactly. It's like a game of telephone where the message gets garbled along the way.
This is feeling like a real detective story. We're uncovering clues and piecing together the mystery of how our brains manage emotions. What are some of the things researchers are looking at when it comes to those connections?
Well, one key area of interest is white matter.
White matter, that's the stuff that connects different parts of the brain, right?
You got it. Think of it as the brain's superhighways, the bundles of nerve fibers that connect different regions. Researchers are using advanced imaging techniques to study the integrity of these pathways, looking for any signs of damage or disruption that might be contributing to emotion regulation difficulties.
So it's like checking the roads for potholes and traffic jams that might be slowing down the flow of information in the brain.
That's a great analogy. They're also looking at the strength of the connections between regions. Some pathways might be weaker in people with certain mental disorders, making it harder for different areas of the brain to communicate effectively.
It's almost like those brain regions are trying to have a conversation, but the signal keeps dropping out.
Exactly. And that can lead to all sorts of problems with emotion regulation.
This is fascinating. It's like we're zooming in on the brain's intricate wiring and trying to understand how those tiny connections can have such a huge impact on our mental health.
It's amazing, isn't it?
It really is, and it makes me realize how much more there is to learn. But after all this talk about brain regions and connections, I'm starting to miss the human element. We've been so focused on the science.
Yeah, let's bring it back to the personal level.
What does all this mean for the individual? What's the takeaway message for someone listening to this, trying to understand their own emotions and how to manage them better?
Well, I think the biggest takeaway here is that if you struggle with managing your emotions, you're not alone.
Yeah, like seriously, who doesn't struggle with this stuff sometime?
Right. We all do. It's part of being human.
But this research gives me hope because it shows that emotion regulation is a skill, not just some like personality trait you're stuck with.
Exactly. It's something you can learn and get better at over time.
So it's like, I don't know, learning to play the guitar.
Exactly. The more you practice, the better you get.
But where do we even begin? Like, what are some practical steps we can take to start building those emotion regulation muscles?
Okay, so one of the most powerful tools is mindfulness.
Mindfulness, that's like paying attention to your breath and stuff, right?
It's more than just the breath. It's about paying attention to your emotions as they arise, without judgment. Just
Yeah.
noticing them, acknowledging them.
So instead of getting all caught up in the story of, oh my God, I'm so stressed, I'm going to fail, my life is over,
Right, all that drama.
we can just observe the feeling of stress as it comes and goes.
Exactly. And the more we do that, the less reactive we become. We start to create a little bit of space between the feeling and our reaction.
Yeah. That space is so important. It's like suddenly you have a choice. You're not just a slave to your emotions anymore.
Exactly. You're in the driver's seat.
So are there other skills we can practice besides mindfulness? Because sometimes mindfulness alone doesn't feel like enough, you know?
Another really helpful technique is cognitive reappraisal.
We talked about that earlier, right? Like changing the way you think about a situation.
Exactly.
Yeah.
So let's say you're dreading a social event because you're feeling anxious. You can try to reframe it as an opportunity to connect with people, to have some fun, maybe even meet someone new.
Instead of focusing on all the things that could go wrong.
Right. You're not denying the anxiety, but you're choosing to focus on a more positive aspect of the situation.
And that can actually change how you feel about it.
It's like changing the channel in your mind.
Switching from the anxiety channel to the excitement channel.
Exactly.
Yeah.
And the more you practice this, the easier it becomes.
Yeah.
You're literally rewiring your brain to be more resilient.
Okay, this is making me feel way more optimistic. But I have to wonder, are some people just naturally better at this stuff than others?
That's a great question. And honestly,
Mm.
probably. There are definitely individual differences in how easily people can learn these skills.
So genetics, upbringing, personality, all that stuff plays a role.
Definitely. But even if you don't feel like you were born with the emotion regulation gene, you can still make significant improvements with practice.
That's a relief to hear.
The key is to be patient and compassionate with yourself.
And to remember that progress, not perfection, is the goal.
Exactly. Every little step you take is a victory.
This has been such an eye-opening deep dive. I feel like I've learned so much about how my brain works.
Me too. It's amazing how much we're still discovering about this stuff.
So any final words of wisdom you'd like to leave our listeners with?
You have more power over your emotions than you might think. With practice and self-compassion, you can learn to regulate your feelings more effectively and create a life that feels more balanced and joyful.